Um, this is an example of a problem that you will have in the test or even on the final exam. Um, on this one, we're going to build a scatter plot. Now, the first thing you want to do for the scatter plot is use your calculator. So we're going to go over here to the calculator. Okay, I'm going to go ahead and get the calculator out. Now, what I'm going to do is I'm going to turn it on, press clear, press that, and press edit. Now, I'm going to enter those numbers in there. So I'm going to go ahead and clear this off, and I'm going to go ahead and clear this one off. Okay, so now I'm going to enter these numbers into this one right here. So that's going to be 30.2, 48.3, 112.3. Okay, that seems to be very big. That, let me see here. Well, we can keep on going. 162.2, 191.9, and 197.8. On the other side, we have 0.15. So we have 0.15. We have 0.35. Then we have the other one is going to be 1. Okay, 1.25, 1.75, and 2. Okay, so now the first thing we want to do is graph a scatter plot on the calculator. To do that, first of all, you have to set the calculator to graph. So you're going to go to second and y equals and make sure that the stat plot, the first one, is on. Okay, make sure that the type is a scatter plot, and then you have L1 and L2. After that, you can just go ahead and go second quit and get out of it. Now you're going to go to zoom and 9. Okay, and when you do that, you get your scatter plot right here. And that's what you're looking for. This is the scatter plot. So that's basically the one that you're going to do. Okay, so let me repeat it again. So you're going to enter the numbers. Okay. Then you're going to go ahead and set it up so that you can do the scatter plot. Then you're going to go to zoom and stat. Then you're going to graph it. So that's the first one. The second one is you want to find the correlation coefficient. So now we still have the same set of data right here. So what we're going to do is we're going to go to our calculator. Okay, go to stat and edit. You've entered the numbers. Now we're going to go ahead and go back here. You're going to go to stat. You're going to go out to calc, and you're going to go out to linear reg a plus bx. So that's number 8. So you're going to press enter. You're going to go L1 comma L2. Now I forgot to check something. I forgot to make sure the diagnostics are on. If you do not have an R squared and R, the diagnostics were off. In this case, the diagnostics were on. Okay, so we have our correlation coefficient is this one, 0.985. So we have that our, okay, so let me review. To find the correlation coefficient, go to your calculator, enter the numbers into L1 and L2, press stat, then calc, then number 8. When you do that, you get the linear reg a plus bx on your screen. You're going to have to go second 1 for L1, press the comma button, and second 2 for L2. Then you press enter, and you get your readout. You're going to have the linear correlation coefficient, which is 0.985. That's going to be your linear correlation coefficient. Now, the other thing you have is basically your coefficient of determination. The coefficient of determination is basically your correlation coefficient squared, and it's right here on the readout, r squared. So it's going to be 0.971. That's your coefficient of determination. It also says that your 97.1% or 97% of the variability is explained by the model. So now the next thing you have is to find the line of best fit. You already have it in this readout right here. Your A is your intercept, your B is your slope. You're going to set it up as an equation. So basically we have A is equal to negative 1.62 plus 0.01 times x. That is your equation. That is your least square regression line. Once you have this, in order to calculate or to make a prediction, just plug it into the equation. And therefore you get your answer. So the predicted value is 1.774.